Okay, we are going to continue with the cross product. So I will write some operations and I will ask you which one is valid. So if we have vector u cross product vector v dot w, is this okay operation or no? We can do that? Yes, we can, because the cross product will give me a vector. Let's say the cross product here will give me a vector. Let's call it, the vector will be perpendicular on both u and v, so let's call it vector p. And I can do p dot w because this is, dot product is an operation that I can perform with two vectors. So this is okay. Let's talk about u cross product v dot w. In here, I will do v dot w first. What will be the result of vector v dot vector w? It will be a scalar, a number, or a vector. We know that the dot product gave us a number. So let's say, so now that means I'm going to do, can I do cross product of u cross product number n? No, because cross product has to be between two vectors, so this is not valid. Okay, what about u cross product v cross product w? This, I can do this cross product, it will give me a vector, and then I can do vector cross product another vector. So this is yes. So I cannot do cross product between a vector and a number. So this is not a valid operation. Okay? So this is the first thing I want to do in this video. The second thing, let's say we are going to have a let's say we have two vectors, vector A which is having this component, so I give you the vector algebraically, negative 0, negative 2, and 1, and vector B which is 8, negative 3, and negative 1. And I need to find the unit vector that is perpendicular to A and B. Unit vector means a vector with a magnitude of 1. Perpendicular, this is the direction of the unit vector we are going to find. It will be perpendicular to A and B. Once I see that I need to find a vector that's perpendicular to two vectors, the only operation that comes to my mind is cross product. So this tells me that I need to do cross product of A and B, of A cross product B. So I need to find A cross product B because this will give me the vector that's perpendicular to both A and B. This will be the vector u, let's say. Then after I found vector u, it will be components like 3, 4, 5, whatever it will be. I will divide this vector by the magnitude of the vector using the square root of the three components added, squared and added together. That will give me, and I'll divide the components of this vector by the magnitude of the vector. That will give me the unit vector in the direction of u. So what I'm going to do when I see a vector that's perpendicular to A and B, I have to do the cross product. So let's do cross product. So A cross product B, I which is 5, minus j. Ignore the column and the row that has j. 0 times negative 1 is 0, minus negative 8, so that's 8, plus k. Forget about the column and the row that has k. 0 times negative 3 is 0. 2 times minus 2, negative 2 times 8, so minus 16, which is 16. So I know that the components of this vector will be 5, negative 8, and 16. This is the vector that's perpendicular to both A and B, not the unit vector. This is the vector u. So let's call this u. If I want to find unit vector in the direction of u, I have to divide the components, all these components, by the square root of the 5 squared plus negative 8 squared plus 16 squared. So this will be 5, negative 8, 16 divided by, I'll do that in the calculator, 25 plus 64 plus 26. 256 plus 64 plus 25, that's 345, square root of that, 18.574, or I can leave it as a square root of 345. So the unit vector, the components of the unit vector will be 5 over the square root of 345, comma, negative 8 over the square root of 345, 16 over the square root of 345. Mathematicians don't like to have radicals in the denominator, so we can multiply the top and the bottom by square root of 345. For me, I am happy if I see this. So this is the unit vector that's perpendicular on both A and B. Okay, so this is another thing I wanted you to know. I want to tell you there are many applications for the cross and dot product, but this one is very important. That's why I'm going to do it now. Let's say we have vector A and vector B are adjacent sides of a parallelogram. So this is a parallelogram. A and B are adjacent sides. The angle between them is theta. If I want to find the area of this parallelogram, this is the area of the parallelogram. So area of the where A and B are adjacent sides, will equal area of any parallelogram is the base times the height. The base here is the magnitude of vector A times the height, which is h. Okay? If we look at this right triangle, we know that sine theta, this is a right triangle because the height has to make a 90 degree with the base, equal h divided by the magnitude of b, opposite over the hypotenuse. So I can say that h equal the magnitude of b sine theta. Okay, so So I can write the area of the parallelogram equals A, the magnitude of A, times the magnitude of B sine theta. When you look at this, you will find that this is the magnitude of the cross product of A cross product B. Remember at the beginning we said that cross product of A, the magnitude of the cross product is vector A, the magnitude of A times the magnitude of B, sine the angle between them. So this is the magnitude of A cross product B. Okay, so that means if I want to find the area of a parallelogram, let's say I give you vector A equal 1, 2, 3, and vector B equal negative 2, 3, and 4. Find the area of the parallelogram where A and B are adjacent, vector A and vector B are adjacent vectors over there. All you need to do is you do A cross product B. This will give you a vector. Let's say, I don't know what it will be, but it will end up with a vector anything, 5, 6, 7, whatever. I don't know. Now I need to find the magnitude of A cross product B. This will be the square root of 5 squared plus 6 squared plus 7 squared. You will get a number. This represents the area of the parallelogram where A and B are cross product. So the idea is if you have adjacent. So the idea is if you have two adjacent vectors, you can find the area of the parallelogram by doing the cross product and getting the magnitude of the vector you will get. Now let's say I want to find the area of a triangle that A and B are adjacent sides. The area of this triangle is half the area of the parallelogram. So I can say area of the triangle equals A cross product B, and then I get the magnitude using this way divided by 2. Okay, this is a very, very, very important application, and it can help us find the area of triangles and parallelogram if we know the components of the two vectors. Okay, I am done with the lesson. I want you to do some homework questions. I will write them in here because I still have a minute. So page 407, number 3, 4, D, E, and F, 5, 7A, 9, 11, A, and B. Okay, please send me your questions. I didn't get questions from yesterday's homework. I hope that this, because you know the answer. Please send me your questions. It's very important for me to know how you are doing. Okay, have a wonderful day, and we are done with the two operations. Now we're gonna use them to find equations of lines and planes and many things. Okay, have a wonderful